Okay, so theory of probability deals with the chances of outcomes of a random experiment only. So here I should say at first, what is this random experiment? Basically, experiments are classified into two categories. One is deterministic experiment and another one is a random experiment. In deterministic experiment, what happens? The outcome of the experiment is known to you. For example, if I combine say two molecules of hydrogen and one molecule of oxygen, what will be the outcome or result? The result will be the water. That means those experiments that we in general we do in physics or in chemistry laboratories, these are the deterministic experiment. তুমি যদি আজকে তোমার মাথা দিয়ে জুড়ে একটা ওয়ালের মধ্যে মারো, তোমার মাথাটা ফাটবে, the result is known to you. This is deterministic experiment. But in a random experiment, what happens? The possible outcomes are known to you, but which particular outcome will come up, that is unknown to you. For example, if I toss a coin, the possibilities are known to us. Either head will come up or tail will come up, but I don't know exactly which one will come up. If I throw a dice, I know 6 possibilities are there, that means 6 possible outcomes are there, 1, 2, 3, 4, 5, 6, but exactly which one will come up, that's unknown to us. So these type of experiments where the possibilities are known to us, but exactly which outcome will come up, that unknown to us, these types of experiment are known as a random experiment. So in your book you have already the definition of deterministic experiment and random experiment. And the theory of probability deals with the chances of outcomes of a random experiment only. Now, before I proceed, some terms should be discussed. Events or outcomes or cases or results, same thing. Events means outcomes or cases or results. If I throw a dice, 1, 2, 3, 4, 5, 6, all these are the outcomes, are also known as events, sometimes also termed as cases or results. Now we can categorize outcomes into some heads like mutually exclusive outcomes, equally likely outcomes, and exhaustive outcomes. Mutually exclusive outcomes. We say that the outcomes are mutually exclusive if occurrence of one outcome prevents the occurrence of other outcomes. The simple example is the coin tossing experiment. If I toss a coin, how many outcomes are there? 2 outcomes are there. Possible outcomes are there, head and tail. Now if head comes up, tail cannot come up, or if tail comes up, head cannot come up. That means occurrence of head prevents the occurrence of tail, or occurrence of tail prevents the occurrence of head. So here the outcomes head and tail are mutually exclusive. Similarly, if we throw a dice, the 6 possibilities or the 6 outcomes 1, 2, 3, 4, 5, 6, these are mutually exclusive to each other. Then equally likely outcomes. If all the outcomes are equally probable to occur, if all the outcomes are equally probable to occur, that means if we cannot expect one in preference to other, we say that the outcomes are equally likely. Take the same example, throwing of a dice or tossing of a coin. In throwing of a dice, these 1, 2, 3, 4, 5, 6, all these 6 outcomes are equally likely to occur. That means they are equally probable. So they are termed as equally likely outcomes. And exhaustive outcomes. Exhaustive outcomes means the totality of all outcomes. The totality of all outcomes. Now in throwing of a dice, the outcomes 1, 2, 3, 4, 5, 6. These are the exhaustive outcomes, because these outcomes are the all possibilities. Now if I say that in throwing of a dice, are the outcomes 1, 2, 3, 4 exhaustive? No, because I have spoken out the outcomes 1, 2, 3, 4. I have not spoken out about 5 and 6. So that means 2 possibilities are left. 5 and 6 has not been mentioned. So 1, 2, 3, 4, these are not exhaustive outcomes. But 1, 2, 3, 4, 5, 6, these are the exhaustive outcomes. Simply the totality of all outcomes are the exhaustive outcomes. So we have seen, if I throw a dice, the outcomes 1, 2, 3, 4, 5, 6. These are mutually exclusive, these are equally likely, and these are exhaustive outcomes also. Now let us discuss about the favorable outcomes. The outcomes which support the occurrence of an event. The outcomes which support the occurrence of an event are called favorable outcomes. For example, suppose I conduct an experiment of throwing of a dice. And I say that I declare an event of getting an odd number. Now, if I throw a dice, how many possibilities are there? 1, 2, 3, 4, 5, 6. These are the 6 possibilities are there. Now, my event, the interested event is the event of getting an even number or say odd number. So, we have to look, I should look out of these 6 possibilities, how many possibilities are odd? Only 3 possibilities are odd, 1, 3 and 5. So how many outcomes are favorable to get an odd number? 3 outcomes are favorable to get an odd number. So out of 6 outcomes, 6 possible outcomes, only 3 outcomes are favorable to get an odd number. If I declare another event, say of getting a prime number when a dice is thrown. So when a dice is thrown, out of these 6 possibilities, how many are prime? 2, 3 and 5. These 3 outcomes are the primes. So number of favorable outcomes here also 3, namely 2, 3 and 5. You have already these definitions in your book, no need to give it, just I discuss. Now see different approaches of probability. Mathematical or classical or priori approach. Then we have relative frequency approach and then this is axiomatic approach or modern approach. In fact, mathematical approach and axiomatic approach, these two are mathematical by nature. These two are mathematical by nature, but in axiomatic approach you will come across this later on. A notion of sample space is attached. Or you can say that in axiomatic approach we apply some set theoretic approach to deal with the probability. But in classical or mathematical approach, that set theoretic approach is not applied. Now in mathematical approach some limitations are there. I will discuss it. That means in all the situations we cannot apply the mathematical approach. So these drawbacks are overcome by a relative frequency approach.